In the second part of Mod 5, we are going to continue example 3, proving identities. And in this case, we have the secant of negative x over the cosecant of negative x plus the sine of negative x over the cosine of negative x. And we are to prove that that equals negative 2 times the tangent of x. The first thing that you should do in this problem is use the even and odd rules. Remember that cosine and secant are the only functions that are even. And when you have an even function, you just take the negative sign out of the expression altogether. So secant of negative x is equal to just secant of x. All the other functions are odd. So cosecant on the bottom will be odd. When you have an odd function and you have a negative on the argument is what you're doing the cosecant or the sine or the tangent of. You pull the negative sign out front on an odd function. So it becomes negative cosecant of x plus sine is an odd function, so pull the negative out front, negative sine of x, over cosine is an even function, so it just becomes cosine of x. Well, now there's no squares, so we are not going to try to use any Pythagoreans. The other thing that we do is write as sines or cosines and see what happens. In the fraction on the left, secant is 1 over cosine over negative cosecant is 1 over the sine of x. Plus over here we've got negative sine of x over cosine of x. I'm not going to do anything with that fraction right now because it's already in terms of sine and cosine. When you have a fraction divided by a fraction, you flip the bottom fraction and multiply. So the left-hand fraction will become 1 over cosine of x times negative sine of x over 1. Plus, we've still got this negative sine x over cosine x, and I'm just not going to do anything with it until I'm finished with the first fraction. Now, on that first fraction, multiply. And when you multiply fractions, you multiply straight across. So you're going to have negative sine of x over cosine of x plus negative sine of x over cosine of x. Well, now, what do I know about sine over cosine? It equals tangent. So I have negative tangent of x plus negative tangent of x. And when I combine my like terms, I get negative 2 tangent of x equals negative 2 tangent of x. And my proof is complete. On example F, we have 1 minus the cosine of negative x over the secant of negative x minus 1 equals the cosine of x. As soon as you see these negative x's on your arguments, use your even and odd rules before you do anything else. Cosine and secant are the only two that are even. So we get to just drop the negative signs on those expressions. So my fraction will become 1 minus the cosine of x over secant of x minus 1. Okay, well now what? Hopefully you recognize that secant is the reciprocal of cosine. So I'm going to leave the numerator alone, and I'm going to rewrite secant as 1 over the cosine of x. Well, now I have created a fraction in the denominator of my fraction. And I'm supposed to subtract those two terms in the denominator. When you are subtracting and you have one term that's a fraction and one that's not, you have to create a common denominator. So our numerator of this fraction is just going to stay 1 minus cosine of x for right now. We are going to create a common denominator in the denominator of the fraction by rewriting 1 as cosine of x over cosine of x. Now we have a common denominator, so we can subtract those two fractions within the denominator. Our numerator still is just going to stay 1 minus cosine of x. Fraction rules say that you subtract or add, depending on the operation. In this case, subtract the numerators, which just becomes 1 minus cosine of x because they are not like terms, and put it over the common denominator unchanged. Now I have a complex fraction that is a single fraction over a single fraction. Remember that when you have a fraction over a fraction, you leave the numerator part alone. So we are going to just write 1 minus cosine of x. We could make it fractional by putting it over 1, but you don't have to. Times, now flip that bottom fraction, cosine of x over 1 minus cosine of x. In looking at what I have here, notice that I have a 1 minus cosine of x over a 1 minus cosine of x. So I'm going to cancel that out, and I am left with cosine of x over 1, which is just cosine of x, which equals the cosine of x, which was our goal. So our proof is complete. The next thing that we're going to look at in this mod are the sum and difference formulas for cosine, sine, and tangent. When you are doing a sum or difference with a cosine, that means that you have two angles that you are either adding or subtracting. Pay attention to the pattern on these, and you'll kind of get used to the patterns as you work through problems. On the cosine, you do the cosine of both angles, and then you do the opposite sign of what was in the original. If you were adding your angles, you are going to subtract your functions. If you are subtracting your angles, then you are going to add the functions. Notice that it's cosine, cosine, and sine, sine on this formula. When you go to the sine version of the sum or difference formula, notice that this time it's sine of the first angle, cosine of the second angle. You're doing sine and then cosine, and then you do cosine and then sine. But in between the functions, the operation that you're doing is the same as the operation you were doing on the two angles. So if you are doing the sine of A plus B, then you are going to add your sine cosine and cosine sine. On the tangent, if we are doing the tangent of A plus B, angle A plus angle B, in the numerator, you do the tangent of angle A, same operation, so it'll be plus tangent of angle B. In the denominator, it's 1, and then it's the opposite operation, so it'll be minus tangent of angle A times tangent of angle B. That pattern is always the same. The numerator gets the same operation, the denominator gets the opposite operation. On example 4, we need to use a sum or difference formula to find an exact value. And on A, the problem that we are given is the sine of 165. As soon as you see which function it is, you know you have to use the sine formula. 165 is not an angle on the unit circle. What we want to do is pick two angle measures that are on the unit circle and either add them or subtract them to make 165 degrees. There are several ways that you can do this. But the first thing that I see is rewriting this as 45. When I see a 5, I know I need to use a 45 somewhere. 45 plus 120. Those are both angles that are on the unit circle. So now we're going to use the sine version sum formula. That formula says you do the sine of the first angle measure, which for us is 45, times the cosine of the second angle measure, which is 120. The operation that we used was plus, so the operation between is also plus. Then we do the cosine of 45 degrees and the sine of 120. Now go to your unit circle. The sine of 45 degrees is the square root of 2 over 2. The cosine of 120 is negative 1/2, plus the cosine of 45 degrees is square root of 2 over 2, and the sine of 120 is the square root of 3 over 2. Do the multiplying that you have. The square root of 2 over 2 times negative 1/2 gives me negative square root of 2 over 4. The square root of 2 over 2 times the square root of 3 over 2 gives me the square root of 6 over 4. We already have a common denominator, so we're going to write this as one fraction. My single fraction would be negative square root of 2 plus the square root of 6 over 4. You leave your answer like this. When it says exact value, that means they do not want you to put those radicals into the calculator and find a decimal value for that. Leave it alone. On B, we have the sine of pi over 12 that we need to find an exact value for. Over 12 is not one of the angles that's on our unit circle. So we have to find things that, if we wrote them over 12, would simplify to be angles that are on the unit circle. Think of something easy that you could subtract to get a numerator of 1. For example, 3 minus 2 equals 1. And 3 pi over 12 simplifies to be pi over 4. 2 pi over 12 simplifies to be pi over 6. So I am going to rewrite this as the sine of 3 pi over 12 minus 2 pi over 12. Now, putting it in the simpler form, it would be pi over 4 minus pi over 6. And those are angles on our unit circle. So because this is the sine function out front, we have to use that version of the formula, which says that we do the sine of the first angle, pi over 4, times the cosine of the second angle. And on this formula, whatever operation you had between your angles, you put between your functions, so it'll be minus. Then we will do the cosine of pi over 4 times the sine of pi over 6. Now we're going to replace the trig functions with what they equal to from the unit circle. The sine of pi over 4 is the square root of 2 over 2. The cosine of pi over 6 is the square root of 3 over 2. Minus cosine of pi over 4, square root of 2 over 2. The sine of pi over 6 is 1/2. Do your multiplying, so you will get the square root of 6 over 4 minus the square root of 2 over 4. Now make it one fraction. You'll have the square root of 6 minus the square root of 2 over 4. Again, leave your answer like this because that is the exact answer. Notice that the numbers are very similar to what we had in the last example, and you will find that you'll have a lot of similar looking answers. On some problems, rather than having you do the addition or subtraction, they will give you the spread out version of the formula. So you have to look at the pattern and notice this is a sine, cosine, cosine, sine. That means that this was a sine function originally. Now we know the two angles have to be 38 and 52. The operation that goes between on the sine version is the same. Well, this becomes then the sine of 90 degrees, but we know that the sine of 90 degrees is 1. On D, we want to find the tangent of 75 degrees. This is not a number on the unit circle, but I can rewrite this as soon as I see a 5, I know I need a 45 plus 30. Now, because my function is a tangent, I have to follow that version of the formula. And that formula says we do the tangent of the first angle, same operation, so it's plus, tangent of the second angle, over 1 opposite operation minus tangent of the first angle times tangent of the second angle. Now we need to substitute in the values for those trig functions. The tangent of 45 degrees is 1. The tangent of 30 degrees is the square root of 3 over 3. I am getting all these by putting the y over the x. In the denominator, we have 1 minus, we already know the tangent of 45 is 1, times tangent of 30 is square root of 3 over 3. This gives us 1 plus the square root of 3 over 3 over 1 minus the square root of 3 over 3. We have fractions both in the numerator and the denominator, so we're going to make those 1s into 3 over 3s, since that's our common denominator. We would have 3 over 3 plus the square root of 3 over 3 over 3 over 3 minus the square root of 3 over 3. Now that I have common denominators, I'm going to add the fractions in the numerator, which would give us 3 plus the square root of 3 over 3. All that over 3 minus the square root of 3 over 3. Since I have a complex fraction, I leave the numerator alone, and then I multiply by the reciprocal, so I'm going to be times 3 over 3 minus the square root of 3. Now here, the single 3's in the numerator and denominator, numerator of the second, denominator of the first, those can cancel. And you are left with 3 plus the square root of 3 over 3 minus the square root of 3. Nothing in this can be simplified any farther because you are adding and subtracting those items. You cannot cancel when you are adding and subtracting. You can only cancel when you are multiplying. So this has to stay in this form. On E, we need to do the cosine of 5 pi over 12. Again, 12s over 12s are not items that are on the unit circle. So we want to figure out a way to either add or subtract to equal 5 pi over 12, that if we simplify, we would get items on the unit circle. When I see a 5, the first thing that comes to mind to me is 2 plus 3. And if I think about that, cosine of 2 pi over 12 plus 3 pi over 12. 2 plus 3 gives me the 5. 2 over 12 is pi over 6. The 3 pi over 12 is pi over 4. So I'm going to rewrite those as the numbers from the unit circle just to keep myself organized. Because this is a cosine function, we have to use that version of the formula, which says cosine of the first angle times cosine of the second angle. Do the opposite operation. Since we had plus between, it's going to be minus here. And then it'll be sine of the first angle times sine of the second angle. Now, look at your unit circle. What's the cosine of pi over 6 equal? It equals the square root of 3 over 2. Take that times the cosine of pi over 4, which is the square root of 2 over 2. Subtract. The sine of pi over 6 is 1/2, and the sine of pi over 4 is the square root of 2 over 2. Do your multiplying, you get the square root of 6 over 4 minus the square root of 2 over 4. Now make it a single fraction, the square root of 6 minus the square root of 2 over 4, and that's your final answer. On F, again, we have been given a spread out version of the formula, and we have to figure out which one it is. When I see that my first two functions are cosine and then my second two functions are sine, that is a cosine version of the formula. So I know the function I need out front is cosine. I know my two angles are 87 and 93. On the cosine formula, what you have between the functions is opposite of what you have between the angles. So it will be plus between our angles. But the cosine of 87 plus 93 is the same as the cosine of 180 degrees. And the cosine of 180 degrees equals -1. On example 5, it says to find the exact value of cosine of a plus b when the sine of a equals -4/5 and angle A is in quadrant 3 and the cotangent of b is -3/4 and angle B is in quadrant 2. I would suggest that you always draw little pictures for yourself just to help you keep organized. The mistake that students make when they don't draw pictures is sign errors. So think about angle A being in quadrant 3. So first of all, let's draw an angle A. Now remember that you always go from the center out and then drop a perpendicular. Angle A is always between the x-axis and the line that you drew. Now, we know that the sine of angle A is negative 4/5. Sine is y over r. So the y value has to be the 4, and the r value has to be the 5. If the sign is negative, which one of those numbers gets the negative? Remember that r cannot be negative. So the 4 has to be the negative, and if you're in the third quadrant, y values are negative. Do the Pythagorean theorem to find your x value. X squared plus negative 4 squared equals 5 squared. So we have x squared plus 16 equals 25. You get x squared equals 9. So x has to be plus or minus 3. If we are in the third quadrant, x has to be negative 3. Now draw an angle for B. What does it tell us about angle B? Angle B is in quadrant 2. So we're going to go from the center out, make a perpendicular to the x-axis. Angle B is between the x-axis and the diagonal line you drew. Cotangent of B is negative 3/4. Cotangent is x over y. So my x value is 3 and my y value is 4. Which one of those gets the negative sign? In quadrant 2, x is negative. Now, if you'll notice, with an x value and a y value of 3 and 4, that's exactly what we had on the other triangle. So that means that the hypotenuse, the r value, has to be 5 on this triangle as well. Now we know what kind of signs we have to worry about. The cosine formula is cosine A, cosine B. Because that was addition, we do minus, do the opposite, sine A, sine B. Now go to your angle A. Find the cosine for angle A. If we are in angle A, cosine is x over r, negative 3 over 5. Now go over to angle B and do cosine. X over r is also negative 3 over 5. Minus. Go back to angle A and do the sine. That's negative 4 over 5. They gave us that, plus we know it's y over r. Go back to angle B and do y over r. You get positive 4 over 5. Do your multiplication. Negative 3/5 times negative 3/5 gives me 9 over 25 minus negative 4/5 times positive 4/5 gives me negative 16 over 25. Combine your terms. They are like denominators. So that's going to be 9 over 25 plus 16 over 25, which gives us 25 over 25. So our final answer is 1. Example 6 is very similar to example 5, but in this case we are doing the tangent. And these symbols, in case you don't know them, are alpha and beta. They are Greek letters. So we want to do the tangent of alpha plus beta. If the tangent of alpha is 4/3 and alpha is in quadrant 3, and the cosine of beta is 4/5 and beta is in quadrant 4. Just like we did on example 5, draw the triangles. So alpha is in quadrant 3. So I'm going to go to quadrant 3, put in my angle, make a perpendicular to the x-axis. There's alpha. We are told that the tangent is 4 over 3. So y is 4, x is 3. But we're in the third quadrant, so both of those have to be negative. And if we're using 3 and 4, then the r value, the hypotenuse, is 5. Let's do angle beta. Angle beta is in quadrant 4. So I'm going to go diagonally out from the center, make a perpendicular to the x. Angle beta is between the x and the line we drew. The cosine of this, which is x over r, is 4 over 5, which means the y value has to be 3, and in quadrant 4, y is negative. Now we have our triangles set up. We need to set up the formula that we need to use. This is a sum for tangent. So the formula that we need to do is the tangent of alpha plus the tangent of beta over 1 minus tangent of alpha times tangent of beta. Now substitute the values for each of those functions. The tangent for angle alpha is y over x, so it is 4/3. Notice that that's what they gave us. Plus the tangent for angle beta, y over x, is going to give me negative 3/4. That goes over 1 minus the two numbers we just used multiplied times each other. 4/3 times negative 3/4. We need a common denominator for the two fractions in the numerator. That would be 12. The first fraction would become 16 over 12. The second fraction would become negative 9 over 12. In the denominator, we are going to have 1 minus 4/3 times 3/4 is 1. So it's minus a negative 1. So in our numerator, combining those fractions, we have 7 over 12 over 1 minus negative 1 is 2. Well, that means we have 7 over 12 times 1/2, which equals 7 over 24.